Right, as we start this lesson, let's take 2 seconds and kind of just recap what we know about the trig angles and everything like that. Is that basically if you start at the positive x-axis and go up, you're going to rotate either positive degree or positive radian. Or if you start at the x-axis and go down, you're going to rotate a negative degree or radians. And as you go throughout that degree or you go throughout that radians, what you're doing is you're rotating let's say an arm, or you're rotating a ray, or you're rotating the radius of your circle. And what you're eventually going to be doing is landing at another point along that circle's circumference. Okay? And those coordinates that you're landing at, or those points that you're landing at, are the ones that involve like the square root of 2 over 2, or 1/2, or the square root of 3 over 2. Okay? And from there, let's see, the other things you know is that if I ask you about the cosine of an angle, what that's referring to is when I rotate that angle, where's that x value I'm landing at? Okay? Sine's the y value that you land at. Tangent's the ratio of y's to x's. And then secant is the reciprocal of your x's. It's a reciprocal of cosine. Cosecant is a reciprocal of sine, so it's a reciprocal of your y values. And cotangent is your x's over your y's, or you can think of it as a reciprocal of your tangent values. Okay, so kind of going a little bit further, we also know that coterminal angles are the exact same angles. It's what you're hitting. If I rotate a full 360 degrees, I'm going to land on that same spot as I keep going around 360 after 360 after 360, and those are coterminal. What reference angles are is that based on that whole fact of if I can just memorize quadrant 1, then technically I can know the rest of that unit circle without really having to memorize the rest of them. So let's start here in example 1. I have an angle that's 298 degrees and 25 minutes. And what we want to do is find the reference angle for it. Well, step 1 of finding the reference angles to know, okay, which quadrant is this one landing in? It's 298, it's past 270, but not quite 360. So this, first of all, is quadrant 4. And in quadrant 4, it says the reference angle, which is theta prime, is equal to 360 degrees minus your theta. So 298 and 25 minutes. Well, the way to subtract a degree that's not in minutes is we've got to convert it. 360 degrees is the same thing as 359 degrees in 60 minutes, because there are 60 minutes in 1 degree, minus 298 and 25 minutes. So keeping on subtracting from there, 359 minus 298 is 61 degrees, and 60 minutes minus 25 minutes is going to give us 35 minutes. And there we go. So the reference angle to 298 degrees is 61 degrees and 35 minutes. And as you look at that, if I asked you to graph that, wouldn't that be in quadrant 1? And all reference angles are always in quadrant 1. Okay? So next is we want to figure out where 8 pi over 5 is. Always that lower number tells you what to divide your hemispheres into. So if I go over this first half, that needs to be 5 equal pieces, or 2.5 up in this first quadrant, 2.5 over there, 2.5 over here, and 2.5 over here. So 2.5 and 2.5 is 5, then 7.5 by the time I get to here, so 8 would be somewhere right in here. So that's a quadrant 4. Okay, and in quadrant 4, the rule is you take 2 pi, this time since we're not in degrees, we're in radians, and we're going to subtract off 8 pi over 5. So 10 pi over 5 minus 8 pi over 5 gives us an answer of 2 pi over 5. And there's our reference angle right there. So what this is basically telling us is the coordinate at 8 pi over 5 is going to equal the coordinate at 2 pi over 5. The only difference is there's going to be a couple sign changes in there, and that's everything. It's a really cool rule when we get comfortable with it. Okay, so now let's actually use the steps, the full steps of defining a reference angle to actually find the cosine of 330 and tangent and sine and so on. Okay, so again, first step was where is 330 degrees? Well, 330 is in quadrant 4, and the x value, the reason why I know it's x is because it says cosine, so the x value in quadrant 4 is definitely going to be positive. So let's check that out. So cosine of 330 degrees is the same thing as the positive cosine of 360 minus 330. And what I'm doing right here in this parentheses, is I'm using the rule. I'm going over to quadrant 4 on that little chart that I drew you guys, and I'm putting in the rule that our reference angle is 360 minus whatever you started with in quadrant 4. So, and the reason why I'm saying positive is because of this part right here. So it's the positive cosine of 360 minus 30 is 30 degrees. So the cosine of 30 degrees is the square root of 3 over 2. And there's our answer. So the cosine of 330 is the square root of 3 over 2, and all I had to know was quadrant 1 and my little reference angle rule. That's it. Okay. So 150 degrees for tangent. 150 degrees, what quadrant is that in? It looks like it's past 90, not quite 180. So we're in quadrant 2. The ratio of the y's to the x's in quadrant 2. X's are negative, y's are positive, so it's going to come out negative. Okay, our rule says the tangent of 150 degrees is going to equal, now the negative, that's the whole part right there, the negative tangent, and insert our reference angle rule. In quadrant 2 it says we're going to take 180 degrees and subtract off what we're starting with, which is 150. So the tangent of 150 is the same thing as the negative tangent of, looks like 30 degrees. Alright, so at 30 degrees, my y value there is 1/2. My x value there is the square root of 3 over 2. So cleaning this up a little bit more, multiplying by the reciprocal of the denominator, canceling off some terms, it's the negative 1 over the square root of 3, or it's the negative square root of 3 over 3. So the tangent of 150 degrees is the negative square root of 3 over 3. And if you wanted to, you can pull out your t-chart and double check. Go to the coordinate at 150 and divide the y by the x, and you should get the exact same thing. It's just this way, all I have to do is just know basically what 5 coordinates that encompass from 0 to 90 degrees, and that's about it. Alright, the sine of 7 pi over 4. 7 pi over 4, if I look at those hemispheres, there's 4 equal parts to there, 4 more to there, so 4, and that's 8, so 7's got to be right in here. So we're looking at quadrant 4. And my y value, sine always deals with y, so my y value in quadrant 4 is definitely negative, because we're below the x-axis. Okay, so let's do some rules. The sine of 7 pi over 4 equals the negative sine of, in that quadrant it tells us to go 2 pi minus the angle we're starting with. Okay, so it's the negative sine of 8 pi over 4 minus 7 pi over 4. So it's the negative sine of pi over 4. And the y value at pi over 4 is the square root of 2 over 2. And there you go. So if we had to find the sine of pi over 4, it's the square root of 2 over 2, but what we're finding is the sine of 7 pi over 4, and that's why it's negative. All right, so let's go on. We're going to use the reference angle rule to find theta, this time in degrees, for the following values. So to get started, first thing we want to look at is for sure the cosine has to deal with x values. And my x values, if I kind of spell that all right, but the x values are going to be negative, see here, in quadrants 2 and quadrants 3. So we're getting 2 answers here. And so basically I want to say is where do I have to rotate to, what angle in degrees is going to give me an x value in that coordinate of the negative square root of 3 over 2. Well, the first thing, let's go to quadrant 1. Let's find that reference angle. When is the first time that we actually get to an x value of the square root of 3 over 2? And as you're going to see, that's going to happen at 30 degrees. So our reference angles here, our theta primes, are going to be 30 degrees. Okay, so the rule says that in quadrant 2, theta prime is equal to 180 degrees minus our original angle, what we're rotating to. So in this case, this time I know theta prime, I want to find theta. So theta prime is 30 degrees is equal to 180 minus theta. Let's swap, if we want to, theta with 30. So theta is equal to 180 minus 30, which is 150 degrees. So if you want to, just go back up to your t-chart or to your table of your circle of values and see at 150 degrees, see if that x value there is a negative square root of 3 over 2. That takes care of quadrant 2. Going on to quadrant 3, the rules in quadrant 3 says to find my reference angle, then what I need to do is take the angle I'm looking for and subtract off. You take off, I drew equals on accident. Then we want to subtract off 180 degrees. Okay, what we do know is 30 degrees, that's our reference angle, and we want to find theta this time. So let's move 180 over, and we get 210 degrees is equal to theta. So if you go look at your chart, go over to 210 degrees, you're going to see that you're going to have an x value there at 210 degrees of the negative square root of 3 over 2. Okay, so let's go on to the next example. We're dealing with cosecant. Cosecant has same thing as, I rather know it as terms of cosine or sine, and secant, how it relates, is our y value. It's our sine value. Okay, so the reciprocal of cosecant is sine. We need to take the reciprocal of this right side, which is 3 over negative 2 square roots of 3. Let's clean this up just a little bit, so hopefully we can recognize it just a little bit more. So it's the same thing as saying sine theta is equal to 3 square roots of 3 over negative 2 times 3. Cancel off those 3's. So this is the same thing as saying sine is going to equal to the negative square root of 3 over 2. So cosecant to equal the negative 2 square root of 3 over 3 is the same thing as saying sine is equal to the negative square root of 3 over 2. Okay, again, sine are our y values, and sine is going to be negative below the x-axis, so quadrants 3 and quadrants 4. Okay, so in quadrant 3, the reference angle rule says my reference angle is equal to theta minus 180 degrees. If I want to go ahead and go to quadrant 4 real quick and write that rule out, in quadrant 4 it says my reference angle is 360 minus theta. Whereas theta prime, we got to figure that one out real quick. Where's the first time in quadrant 1 that you encompass a y value of the square root of 3 over 2? So don't even worry about the negative part. We're going to take care of that. But where's the y value the first time? The square root of 3 over 2. And as you're going to see, that happens first and foremost at 60 degrees. Okay? So 60 degrees is equal to theta minus 180. Let's move 180 over. We get 240 degrees is equal to theta. And like I said, always go back and double check. 240, first of all, is for sure in quadrant 3, so that's good. And you can go check your y value there at that coordinate. Here, 60 degrees is equal to 360 minus theta. Let's move that over, move the 60 over that direction, and you get theta to be 300 degrees. Box that one up, and we can call that one done.